Welcome to Chapter 10, Section 6, more angle arc theorems. This video is going to give you a quick overview of what we're going to cover in this section. Just a few more relationships between angles and their inscribed arcs dealing with circles. So we're going to recognize congruent inscribed and tangent chord angles, determine the measure of an angle inscribed in a semicircle, and apply the relationship between the measures of a tangent-tangent angle and its minor arc. So to start things off, let's take a look at Theorem 89. Theorem 89 states if two inscribed or tangent chord angles intercept the same arc, then they are congruent. All right, so what this means is we have this yellow angle here, CBD, and we also have a blue angle, CAD. And if you notice, they both intercept the circle at this arc, CD. Okay, now that arc is the same for both of them. So we know that the measure of angle B is equal to just 1/2 of the measure of the arc CD. Okay, that's what we learned in the last section, that when the vertex is on the circle, it's half of the inscribed arc. All right, and if we look at the measure of angle A, well, that's also going to be 1/2 the arc of CD. So that means that angle A and angle B are congruent because they have the same intercepted arc off of the circle. Well, we could use the same reasoning for angle C and angle D, because if you look at the arc at which they intercept on the circle, it's this BA, and so they have the same arc. Those angles are congruent. And of course, another way to come about that is looking at vertical angles here and using no choice. But either way, whenever we have these two pairs of angles inside a circle and they intercept the same arc, then we have congruency, and that's our Theorem 89. So if I were to tell you that, hey, the measure of angle B is equal to 20 degrees, well, then you could tell me the measure of angle A, and if you had more information about the measure of angle C or D, you could conclude more. Okay, the next theorem, Theorem 90, tells us that if two inscribed or tangent chord angles intercept congruent arcs, then they are congruent. All right, well, the reasoning to this shouldn't be too much of a stretch, in that if I tell you that AC, arc AC, is congruent to arc XY, okay, well, we look at angle B. Where's the vertex? Is it in, out, or on the circle? It's on the circle. So we know that B is just half of AC. So we know the measure of angle B, well, that's just going to be 1/2 of the arc AC. Well, Y, we look once again, and is the vertex on, in, or outside? Well, it's on the circle, so the measure of angle Y is just simply going to be 1/2 of the intercepted arc XY. Well, if these two arcs are the same, well, then the angle measures are going to be the same. So this should make intuitive sense. So we don't necessarily have to have the exact same arc, but if I tell you that AC and XY, if those two arcs are congruent, marked here, and angle B is 30 degrees, well, then you can conclude that angle Y also has to be 30 degrees, or vice versa, depending on the situation. Next theorem we have is Theorem 91, and this is pretty straightforward. It just tells us that an angle inscribed in a semicircle is a right angle. Okay, so anywhere we move angle C, this is always going to be right. It doesn't matter where we put it. If A is the center of the circle, C is always going to be right. Any point that we make from D to B and we join D and B, it'll always be a right angle. Now, once again, using one of the definitions that we had in the last section of whenever an angle vertex is on the circle, it's equal to half the measure of the intercepted arc, this should make sense. D to B, that arc is 180 degrees because it's half of a circle, so it's 180 degrees. Well, this angle is just half its intercepted arc, so half of 180 is 90 degrees. And that will happen no matter where you put C anywhere along this semicircle. And the final theorem of this section is Theorem 92, and that says the sum of the measure of a tangent-tangent angle and its minor arc has to be 180 degrees. So let's say we call this minor arc x. Doesn't matter what that is. It could be 10 degrees, could be 50 degrees, whatever it may be. This minor arc dB, we call that x. Well, that would mean the major arc dB has to be 360 minus x, because the sum of those two is the full circle, which has to be 360 degrees. So if that's the case, then we can find the measure of angle C to be 1/2 the difference of these two angles, 360 minus x. And if we simplify this, this becomes minus 2x, and distribute the 1/2, we get 180 minus x. And so that means the measure of angle C is just 180 minus the measure of the minor arc, which means that the sum has to be 180. So basically where we get to use this is I tell you that, all right, measure of angle C is 40 degrees. What is the measure of the minor arc dB? Well, the measure of the minor arc dB has to be 180 minus 40, so it's 140 degrees. All right, that about sums up section 6 of chapter 10. Take a few moments, look over the homework for this section, get some practice in, and we'll do some more in class next time I see you.